When we talk about concentration, we've seen concentration before, and we know the formula as being C is equal to M over V. And what that actually stands for, C is concentration, M is the mass of solute, or the amount of solute in grams, in a given solution, in the given amount of solution, and solution is always the volume of the final solution, in milliliters. We know general concentration as being grams per milliliter. Okay, that's usually the units of, actually it's grams per liter. Milliliter is actually not correct. Grams per liter. Okay, so grams is mass of solute, liter is the volume of the final solution. Now, this unit here is not the only way that we can actually express a concentration. There's a variety of different ways. And these letters may throw you, but if you understand what they actually mean, they all mean the same thing. It's an amount of a solute, and we know that a solute doesn't necessarily have to be a solid. A solute can be a liquid. Okay, in a given amount of a solvent. A solvent doesn't necessarily have to be a liquid either. It can be a solid. So when we look at these different ways of expressing it, we're going to explain what each of these units means. So another way of seeing concentration, okay, there's a variety of other ways to express concentration. The symbol for concentration is an open bracket and a closed bracket, okay, with nothing in between. One of the first ways is the percent of solute, okay, percent mass over total volume. All right, and when we see this percent M over V, we're actually looking at a solution of 100 milliliters. Every time we see percentage sign, the final volume or the overall volume will be 100 milliliters, because percentage means 100. If you get 94% on a test, you got 94 of the available marks out of the 100 available marks. Okay? So in this case, if I say that I've got a 5% solution, okay, what I'm actually saying is that I've got a solid solute, because it's percent M, okay, the mass of the solid. I've got a solid solute, so I've got 5 grams of solute in 100 milliliters of solution. Okay, every time you see the word percent or the symbol percent here, it's going to be in a 100 milliliter solution. Okay, so if you say that you've got a concentration of 5 percent solution, or 5% M over V, what you're actually saying is you've got, in that 100 milliliter solution, you're going to have 5 grams of solute in there, in that final volume of 100 milliliters. So in this case, the percent V over V, or volume over volume, means that your solute will be a liquid. And whatever percentage you're given, it will be in milliliters. So if, let's say, I'm given a concentration of 15% V over V, it means that I'm going to have 15 milliliters of solute in 100 milliliters final volume, which means that 15 milliliters out of that 100 will be my solute, and how many milliliters will I need to make up 100? I will need 85 milliliters of solvent, because I want my final volume to be 100. So if I have a beaker here, a graduated cylinder, okay? If I have this, I'm going to put my 15 milliliters. So down here is my 15 milliliters of my solute. And then because it's a percentage, I know that my final volume has to come up to 100. 100 is up here. So then I am going to add 85 milliliters of solvent. Okay, and those should equal 100. As soon as you see that percentage sign, you know that your final volume is going to be 100 milliliters. Okay? The last type of potential concentration you could see involves a solid solute mixed into a solid solvent. Okay, so we express that by percent mass over mass. And what that means is, it means that there's an amount of solute in grams mixed into an amount of solvent also in grams. All right, so the example I'm giving you is I'm saying there's a concentration of 8% mass over mass of toxins in the soil. So if I take a beaker here, and I say I collected a soil sample, and I calculated that there's 8%, 8 grams of toxins in 100 grams of this sample. Okay? How many grams of solute, of regular uncontaminated soil will be in this solution? 92 grams. Okay, I'm going to need the rest of this soil, all of this stuff, and again, that's all mixed in together. Okay, it's not the toxins at the bottom and the good stuff on the top. This is all mixed together, but I'm telling you that in a concentration or in a sample of 100 grams of soil, if I go out and I collect 100 grams of dirt in the ground, okay, or soil, and I get it analyzed, then they come back and they say, there's an 8% mass over mass concentration of toxins in this soil sample. What it's actually saying is in that 100 grams of soil, 8 of those 100 grams are toxins. The other 92 grams of that 100 grams, regular soil with other stuff in it that we're not measuring. Okay, so this is just another way to express a concentration. And they use this when they're talking about a solid and a solid. Okay? And anytime you see that good old percentage, you know that the total amount of the sample they're looking at is 100. If you see a V there, it's 100 milliliters. If you see an M there, it's 100 grams because it's a percentage. So in this case, okay, percent volume over this is a concentration. What they're saying is in a 100 milliliter solution, 15 of those milliliters are that substance that you're looking for. The other 85 are just regular whatever solvent. Okay? In percent mass over volume, this is another way of explaining a concentration. And it says that because we see the M here, this is a solid in a liquid. So it's like juice crystals in water. Okay, that's the prime example. And I'm saying that if I have whatever number percent, that is going to make up a portion of that solution. Okay, of that 100 milliliters. I know that it's going to be milliliters because I see the V there. Okay, and I know that this is going to be grams in my 100 milliliters because I see the M. Does that make sense? So we've got 4 different ways of expressing concentration. We've got our classic grams per liter, which is what we're all used to. We've got then the rest of these are all percentages. We've got our percent mass over volume. We've got our percent volume over volume. And we've got our percent mass over mass. This just means, okay, an amount of solid in a total liquid volume of 100 milliliters. This next one is an amount of liquid solute in a total amount of 100 milliliters. And the final one is an amount of solid solute in a total of 100 grams, because we're looking at an M here. These are the 4 different ways that we can see potential concentrations given to us.